Okay, but let's get into the topic today, and welcome for this presentation. I'm going to cover a couple of things, and because the field is actually quite broad, I cannot go into detail for many things. So I have a couple of case studies where we're going to look at some important issues together. So the topics will be a little bit state-of-the-art of construction in Europe or Switzerland. There are many slides from Switzerland. I would think that state-of-the-art Switzerland corresponds to state-of-the-art Europe. We're talking and doing the same things. Connections are a very important issue, so we'll see some details there. I think the key of modern construction is prefabrication in general, that everything has to be prefabricated off-site, brought onto the site and be erected very quickly, protected from rain and so on. Various types of constructions are available. If you're looking at housing, for instance, prefab, there's always the question, should you have something like a volumetric modules, or rather prefabricated elements in wall, roof, and floor situations. So I think now the trend is a little bit getting into rather prefabrication of elements and erect them very easily on site. So you will see a couple of constructions from very small buildings to really large buildings as well. Also some multi-story buildings. And I will finish up with some words on the curriculum we have at our school. So as Adam said, we are a highly specialized school in Switzerland. The University of Applied Sciences is a small university, maybe about 8,000 students. The Department of Architecture, Wood and Civil Engineering, that is where I'm working in, is only maybe something like 800 to 1,000 people. But the key thing we're doing there, we think timber, we teach timber, we research in timber. And we actually forward all this knowledge to the industry. And so for us, working with timber and building with timber is a kids play. As you can see here, even playgrounds in timber to make people sensitive for that early. I will just focus on some key principles to start with. I think one of the important aspects is to have the right material in the right place. You should build to the requirements. I think very often timber people try to get a better solution that is actually required to show that they're better than steel and other materials, which is not really needed. I think it's a goal to really get what you need finally. Connections are one of the key issues, and I think there's some principle will be shown as well, prefabrication in general, and all, of course, under the aspect of robustness and durability. So you will see some applications for a specific project. So here is a project that shows a little bit how we treat or how we deal with timber on the outside. This is a little bridge over a 4-lane highway. It's for foot and bicycle traffic. What you can see is that all the load-carrying structure of this central part is very well protected from weathering. So it has a roof, it has a facade. This is going back a little bit to our history. We have many bridges, 300 years old, 500 years old, which are still in use. They are covered on the sides, on the roof, and this just makes a very big durability to the timber. You can also see the approach ways. There's some structural timber in there. Everything is nicely covered and clad up. This is the jumper. You can move it, remove it. You can repair it. You can replace it. So this is one of the key issues. Otherwise, it's a fairly simple structure. Not everything in this structure has to be in timber. As you can see, some of the hangers to make them a bit finer, more likely for lighter structures, can also be in steel, or the portals at the end to bring down the high horizontal forces due to wind action on this bridge are brought down by strong portal frame in steel, and then let's say the sections match pretty well to give a nice view on that timber.